Good morning. I'm Scott, and today I'm showing off the Rover 20 that we've spent basically 6 months on and off rebuilding. Well, not so much rebuilding. It's all been all software and a Linux CNC conversion. So first I just want to go over the bits and pieces of the machine. We've got a 9 horsepower spindle with a quick change tool changer, currently with a 2-inch tool in it. We've got sub spindles, you've got a bunch of drilling. You can also do simultaneous drilling, so if you need to make a lot of holes. My plan is to use these for a custom designed cribbage board that works around the spacing. Over here we've got the gantry linear rails, which I thought was just really cool because they're just down the side here and here, so the whole x-axis slides along these. And we've got our gear here, which the pinion on the servo motor interfaces with to move the machine up and down. Over here on the machine we've got our very small 3-tool carousel. We still haven't configured it to work with Linux CNC because we have to build out the macros that coordinate all the pneumatic controls. Here you've got all the pneumatic switches for everything that's to do with this, including opening and closing the cover and rotating the carousel 2 to 3 spaces for each ISO 30 tool. On the back side in here we've got our sub spindle, which is a 3 horsepower motor that drives all of this gear here together. So if you rotate the ripping saw holder, which I don't have a ripping saw installed in right now, all of these tools will rotate together, which is just trippy because it's not a lot of force to rotate 15 or so tools. Yes, it can drill in X and Y sideways. So I am looking forward to use up the 4 inches of minimum 4 inches of Z travel to do kind of sort of 3+2 milling on this machine, but not going to do a ton of that because it bends the mind to write G code for it. Anyway, bends my mind anyway. Back here we've got our I want to say Acme, but I know it's a ball screw. Pardon me, ball screw that moves the y-axis back and forth, and then our motors are on the other side. Up here inside, I'm not going to take the cover off right now, but there's a ton of relays that control all of the pneumatics that fire out all of the sub-tooling. So there you've got all those pneumatics. Just going to walk back around. Now I picked this machine up in so-called working order, and it did, like it fired up, the control worked, but I couldn't get any compliance out of it. Anyway, one thing I love about it is these huge empty cable trays. There's just, well, yeah, cable I don't know what the proper term is. There you got your oil to pump into all of the things. I need to get a proper oil pump for that. There's your y-axis servo, and these I believe are all 400 volts, which is kind of scary. Down here is your x-axis servo. This thing is terrifying. The whole machine can rapid, I think it's 2,700 inches per minute in the x-axis, which like makes me worry that the whole gantry could just go sailing out the garage into the driveway, which would be terrifying. One of the most perplexing things about this machine is its y-axis is only 41 inches, and I even moved the stops to just give myself a little more travel there. We've got pneumatic compensation on the Z-axis, so you're actually pumping in compressed air to lift up the main spindle and compensate for gravity, so that the little tiny Z-axis servo can lift the whole enchilada up. I mean, there's a lot of weight there with the 2 spindles and all the sub-tooling and all that fun stuff. Moving on to the control box, we did have a dead spindle driver, so we replaced that with this guy. Got some ladder logic inside, which is just fantastic. So you can actually have this look at other things, like is the tool locked in the spindle before it can turn on? Because apparently, according to the manual, if you start up the main spindle, you will break something. It's basically a transmission inside there. Here we have our X, Y, and Z axis drivers. I'm curious because they're different size motors, but all the same drivers. Here we've just got an old Core 2 Duo running Linux CNC, and yeah, that just interfaces with all the hardware through a parallel port. I don't want to pull this thing off the wall to show off the parallel port and all that. This is your transformer. I cannot believe this thing can take a wide range of power inputs as far as voltage. It's all three-phase, but it goes like, I think 600 volts down to 220 volts three-phase, and there's a whole breakout inside showing all of your different voltages and how to configure all of these taps here. So that was something else. Again, I'm into this machine for about $5,000, and I even bought a trailer to tow it back home just because it was such a good deal, I thought. And I'm very happy with it so far. Considering, like, back in 1997 when this was built, it was like 75 grand. Now, I know it doesn't have all the newest, flashiest, bestest, but it's good enough for my garage. Yeah, so that pretty much completes the tour. This is the PC I use for all of the G-code, just an i7. Fan collection system. I still have to 3D print a proper shroud that goes onto the spindle. And yeah, that's my Bessie Rover 20 that I think I got for a steal of a deal. Right now we got the spoil board bolted on. I use a whole bunch of these guys. These are great because you can slide them around. You can have a ton of different work-off sets. That's one thing I want to get better at, is having a setup portion of the table and an operating part of the table. Anyway, that's all for me. Hope you enjoyed. If you have any questions about how to get some of these old Bessie machines running, let me know in the comments. Cheers. Have a great day.